This is a Cartesian plane, also known as a coordinate plane or an XY plane, or a rectangular coordinate system. Have you ever played Battleship? When you're playing Battleship, you would call, for instance, D4. And D4 would mean you go and find the D on one end and the 4 on the other end. And where the 4 and the D meet, that's where you would strike D4. A Cartesian plane, a rectangular coordinate system, works the same way. This horizontal axis is the x-axis. This vertical axis is the y-axis. The x-axis is just your standard number line. 0 in the middle, positive numbers to the right, negative numbers to the left. The y-axis is a number line straight up and down. 0 in the middle, positive numbers up, negative numbers down. I'm going to go ahead and clear these numbers out of here just to declutter a bit. And I'll indicate positive, negative again. So positive numbers to the right, negative numbers to the left, positive numbers up, negative numbers down. This is separated into 4 quadrants. We start numbering our quadrants in the top right, and we move counterclockwise. So that's against the direction of a clock. Clock goes this way. That's clockwise. We go counterclockwise when we're numbering. 1, 2, 3, 4. Okay. And we use Roman numerals. 1, 2, 3, 4. Quadrant 3 is lower left. Quadrant 1 is upper right. Quadrant 2 is upper left. Quadrant 4 is lower right. A point, say this one here, 1, 2, 3 to the right, and 1 up, would have both an x coordinate based off of its position on the x-axis and a y coordinate based off of its position on the y-axis. And these coordinates are going to be of the form x comma y, where x and y are in parentheses. So in parentheses, there are 2 coordinates. The first is an x, the second is a y. And this one here, the x, 1, 2, 3, positive 3. The y, 1, positive 1. So this point would be the point 3, 1. Notice it's a positive number and a positive number because it's in quadrant 1. And anything up here in quadrant 1 is going to have a positive x because it's to the right, and it's going to have a positive y because it is up. So all points in quadrant 1 will be positive, positive. All points in quadrant 2 then are going to be negative positive because the x is negative. It's going to be to the left, but the y is positive. It's going to be up. 3. Quadrant 3, the x will be negative because it's to the left. The y will be negative because it's down. Quadrant 4, the x will be positive because it's to the right. The y will be negative because it is down. When we draw ourselves a coordinate plane, you don't have to put in quadrants 1, 2, 3, and 4. You don't have to put plus, minus. All you have to do is make the coordinate plane, label your x-axis, and label your y-axis. That's all you need, an x and a y. So let's find the point -3, 5. Well, our first coordinate is the x, our second coordinate is the y. The x should be -3, and the y should be 5. Now, I'm not going to put a mark here and a mark there, but I am going to kind of tell you to imagine where these intersect, just like Battleship, an x of -3 and a y of +5. Just like Battleship, where they meet is where our point will be. And let's say it's point B. We can call that B. Zeros are where things might get a little cloudy for you. So let's learn a little bit about our zeros here. First of all, we got the double zero, and it's going to be right here because it's a 0 on the x and it is also a 0 on the y. This actually has a special name. That special name is the origin. Let's say we had this point right here. In fact, let me change the position of that. That's under the light spot. Let me go with this one down here. The x is still going to be 0 because it's not going left or right any on the x-axis, but it did go down. It went down 1, 2, 3, 4, 5. So this point would be 0, -5. We'll talk about that in a second, but I also want to talk about this point right here. Now the x is 1, 2, 3, 4, but the y has not moved any from 0. So the y is 0. What I want to point out here is that something that's directly on the x-axis, the horizontal axis, has a y of 0. Something that is directly on the y-axis has an x of 0. These types of points that happen to fall right on the axes are called intercepts because they intercept the axis. An x-intercept intercepts the x-axis. It has a number for x, but a y of 0. So an x-intercept has a y of 0. A y-intercept intercepts the y-axis. It is on the y. It has a number for y, but an x of 0. Let's say we had the equation y equals x plus 2. A solution x, y would be an ordered pair. And by the way, that's what we call these, ordered pairs, because order matters. It's a pair of numbers where the order matters. The first is always x, the second is always y. If you switch them around, it wouldn't be the same thing because the first is always x and the second is always y. So a solution, xy, would be an ordered pair that makes the equation a true statement. Now, maybe you're suffering from whiplash right now. You might be going, hold on, you were just talking about a graph. You were putting points on there. Now we're talking about an equation. Tell me, what's happening? Well, what's happening is I'm showing you that an ordered pair, those things that we're putting on the graph as points, would express a solution to an equation if it's true. So let's test out a few possible ordered pairs and see if they are solutions to this equation. Let's test 0, 2. Let's test -4, -2. Let's test 2, 4. Remember, when we see an ordered pair, what we are seeing is x and y. So let's test this one. X is 0, y is 2. That one's true. So that is a solution. Let's test the second one. X is -4, y is -2. So -2 equals -4 plus 2. -4 plus 2 is -2. Boom, that one checks too. So that one's a solution. Let's check this one, 2, 4. X is 2, y is 4. That checks out. So all three of those are solutions. Does that mean everything's a solution? No. It means that these three are. But guess what? I picked these three because I knew they were. Let's try 1, 8. X is 1, y is 8. That one doesn't check. That one's not a solution. It's only a solution if it satisfies the equation. If when we plug in X and Y, we get a true statement. Let's bring our coordinate plane back. X, Y. These ones that were solutions, let me go ahead and plot these points. 0, 2 would be an X of 0 and a Y of 2. -4, -2 would be an X of -4, so left 4, down 2. 2, 4, it's an X of 2, 2 to the right, a Y of 4, 4 up. Well, you look at that. Well, don't use a cloth as a ruler. That's what we just learned, everybody. A cloth is flimsy. It does not serve the purpose of a ruler. It's much easier to freehand it. But notice, look at these three solution points. They all fall on the same line. That's why an equation that only has x to the first power and nothing higher is called linear. Because if you take all the solutions, they form a line. Points on this line will be a solution. Like here, this is a point on the line. What is that point? -2 on the x, 0. Surely does check. Plug in -2. -2 plus 2 is what? 0. Now, by the way, I want to make a note. I had to be really careful to try to make these equal distant. Because when you're drawing them out, if the tick marks aren't the same size apart, your line's going to get all wonky. You don't want that. So let's go ahead, graph another equation. By the way, that's kind of what we did there. We just graphed an equation. We graphed an equation by plotting points. Let's do the same thing with x minus 2y equals 0. Well, what we can do is solve this equation for y. Now, why would we do that? Well, it'll allow us to pick our x's and then plug them in. Here, I'll show you. If we solve this for y, subtract x from both sides, oops. Subtract x from both sides, divide both sides by -2. Y equals negative divided by negative is positive. Y equals x over 2. So to get a y coordinate, all we have to do is take an x and divide it by 2. Let's make an xy table. What that means is make a table of x's and y's. Since we're going to want to be able to divide the x by 2, our x's that we pick should be even numbers. And I'm going to pick a couple of negatives. I'm going to pick a 0, and I'm going to pick a couple positives. Unless the table's already given to you, you do not have to pick specific x values. Because the whole purpose of an x is to find the y. -4 divided by 2 is -2. -2 divided by 2 is -1. 0 divided by 2 is 0. 2 divided by 2 is 1. 4 divided by 2 is 2. Now, another thing you could have done is just, we're going to come back to what to do with these points in a second. This is like a pause. This isn't more of the same. This is another thing you could have done. Just start by picking some x's and then plugging them in. So if you plug in -2 and then solve for a y, you'll get your y. It just so happens, since you notice -2, -1, we got that point anyway. It's just that if we were putting in, say, a -1 here and solving, you'd end up with fractions. Those would still be on the line, but for graphing purposes, it's a lot easier if you're graphing whole numbers and then not having to figure out, okay, what's half, what's a fourth. So by solving this equation for y first, when it was still in terms of x, it kind of gave us a clue of what kind of x would give us whole number y's. But really, to draw a line, you only need 2 points. 2 points are enough to make up a line. But let's plot all 5 of these. Give a graph, label y, label x. Looks like we need 4 at least in all directions. Try to keep them equal. If you have graph paper, that makes things a lot easier. So -4, -2, that's an x of -4. A y of -2, that's right here. -2, -1, an x of -2, a y of -1, that's right there. 0, 0 is right there. an x of 2, a y of 1, that's right there. An x of 4 and a y of 2, that's right there. So you can kind of see there's our line. And we put arrows on both sides of the line to indicate that it goes off in both directions forever. So that's graphing an equation by plotting points. Let's do another. Let's do x plus 3y equals 3. Well, I could just start picking a bunch of x's, but seeing that y is multiplied by 3 here, that tells me that there's going to be some weird dividing by 3 stuff going on. So I'm going to go ahead and solve for y. I'm going to solve for y by subtracting x from both sides. So 3y equals 3 minus x. I'm going to divide both sides by 3. And y is going to be 3 minus x over 3. So let's make our x and y table. We know how to get our y's. We're going to pick our x. We're going to plug it in. We're going to get our y. Okay. So I'm going to go ahead and pick a couple negative x's. Ooh. I want to be careful with how we pick again. If I just randomly pick some x's, I'm going to run into the same situation, but it has to be something that I can go 3 off of and then divide by 3. So since we're going to be skipping 3 off of it anyway, if x was divisible by 3 and we did 3 minus that x and divided by 3, we should get some nice even y's. So I'll pick some multiples of 3. -6, -3, 0, 3, and 6. These should work. And this is just me thinking it through. You can just pick a bunch of things if you want until you have 2 that did work, that were graphable. If I plug in -6, 3 minus -6 over 3 would be 3 plus 6 over 3, which would be 9 over 3, which is 3. If I plug -3 in, 3 minus -3 is 3 plus 3 over 3, which is 6 over 3, which is 2. If I put 0 in, 3 minus 0 is 3, 3 over 3 is 1. So 3 minus x over 3. If I put 3 in, 3 minus 3 is 0. 0 over 3 is 0. If I put 4 in, or sorry, if I put 6 in, 3 minus 6 is -3. -3 over 3 is -1. So for x plus 3y equals 3, looks like 6 -6, 3, -6 for the x, +3 goes up. -3, 2. And again, I'm pulling these right out of the table. X and Y just becomes an ordered pair. X and Y just becomes an ordered pair. -3, 2. -3 on the X, 2 on the Y. 0, 1, just pulling it right out. 0 for the X, 1 for the Y. 0, 1 goes right there. 3, 0. That's there. 6, -1. 1, 2, 3, 4, 5, 6. Down 1. My lack of foresight, not having a ruler here, means that's the best we're going to do with that line. I am not an artist. Another thing you can do to graph is just identify the intercepts. That's a nice, easy 2 points. So what do I mean there? So 2 points is enough to draw a line. So assuming they don't end up being the same point, let's look for where x is 0 and where y is 0. That'd be finding the intercepts. When x is 0, that's a y-intercept. That'll be our point on the y. When y is 0, that's our x-intercept. It'll be our point on the x. If we plug in 0 for x and solve for y, we get y equals 1. Plug in 0 for x, plus 0 is itself. 3y equals 3. Divide both sides by 3. That's what happened there. Y equals 1. Let's plug 0 in for y. So again, x plus 3y equals 3. If we plug 0 in for y, 3 times 0 is 0. X plus 0 equals 3. X plus 0 is just x. So x equals 3. Now be careful. This is 2 separate points. It's not a point where x is 3 and where y is 1. That is something completely different, unrelated. This is 2 separate points. One where we plugged 0 in for x and got an answer of y. So that's our 0, 1 point. A second point where we plugged 0 in for y and got an x. That's our 3, 0 point. 3, 1, not a point that would satisfy this equation. But once we found our intercepts, the only time this won't work is when it's 0, 0, because that means it'll be the same for both, and we would need to pick another number to get a second point. But once you find your intercepts, all you have to do is plot them. 0, 1, so no movement on the x, but 1 up for the y. 3, 0, no movement for the y, but 1, 2, 3 to the left. There's our 2 points. And we draw our line through them. It's the same one as the one we did those 5 points. But we didn't have to do any weird solving this way. All we do is plug 0 in for x to get one of the points, plug 0 in for y to get the other one of the points. So, new equation. New equation. 3x plus 5y equals 10. And actually, I don't want to do 3x right now. I want to do 2x. 2x plus 5y equals 10. Let's plot using intercepts. So we want to find the 2 points. My old high school Algebra 2 instructor used to call this the googly eyes method. 0 for x, 0 for y, like a pair of googly eyes. If we plug 0 in for x, two times 0 is 0. 0 plus 5y is just 5y. Divide both sides by 5. We get y equals 2. The googly eyes method, it's also called the cover-up method. Why? Because when we plug 0 in for x here, that x goes away. And we can see 5y equals 10, y has to be 2. Let's go ahead and find the other point. We're going to do that by taking the same equation and plugging 0 in for y. So 5 times 0 instead of 5 times y. 5 times 0 is 0. 2x plus 0 is just 2x. Divide both sides by 2. When y is 0, x is 5. Again, cover-up method. When y is 0, so 2x equals 10, x is 5. Once we have those 2 points, the x-intercepts at 5, the y-intercept is at 2. X-intercepts at 5, 5, 0. Y-intercepts at 2, 0, 2. Those are our 2 points that we can then use to draw the line. Even if it doesn't work out to whole numbers, you can still use the intercepts. If it asks you to use the intercepts to find it, then you have to. If it gives you a table to fill in, then you have to. But if it just says graph by plotting points, or it just says graph and doesn't specify the method and how to graph, then you can use any method available. Let's look at 2x plus 3y equals 4. Let's find the intercepts. XY method with the googly eyes, 0 for x, 0 for y, 2 separate lines. If we plug 0 in for x, this goes away. We're left with 3y equals 4. Divide both sides by 3, we get y is 4/3. For the sake of graphing that, we're going to change it to a mixed number. So 4 divided by 3. 3 goes into 4 once. And we want the fraction remainder. 1 1/3 is our y. 1 1/3. 4/3 is a fine answer too. It's just I know I want to graph it. And if you tell me to graph 4/3 and you tell me to graph 1 1/3, I know which one I'm going to be able to find quicker. Let's go ahead and plug 0 in for y. Plugging in 0 in for y, plus 3 times 0 plus 0. That goes away. 2x equals 4 is what we're left with. Divide both sides by 2. We get x equals 2. If I were to graph these points, I'm going to do the one without the fraction first. X is 2 and y is 0. That's an x-intercept. When x is 0, y is 1 1/3. So if I imagine that between between 1 and 2, this got split up into thirds. 1, 2, so it's 1, 2, 3 pieces. 1 1/3 would be right here. And then use your straight edge. You just fold up a piece of paper. Use your straight edge to draw the line between those 2 points. So that's how you'll plot intercepts.